Next, we'll see the third approximation, or otherwise we can call as the piecewise linear. So now we can see how to go for this approximation. See the first ideal diode. Second thing is along with the connected one barrier source. Now again, what they are going to do, just we are going to draw the like this. Okay, diode. Then we are going to draw the one barrier. Okay, next we are going to draw. It will offer the resistance. So now this is minus, this is plus. Now we can say this is nothing but our VB, as we know the VB is nothing but 0.7 voltage. What about this? This is nothing but RD, that is diode resistance, or we can put dynamic resistance also. Now let us say what will be the diode across voltage. See, this is complete VD now. What is the VD? So now in this, at this point in this diagram now, how you will get the figure. Okay, so I need to show now that also. Okay, simple. We'll show here. Let me put this will be your VD. This will be your ID. So now in this, when the forward bias and the diode is in the forward bias, in the sense if the forward voltage is greater than 0.7 volt, then we know that the diode will conduct. If the diode conducts, then automatically then the voltage drop across will become 0.7. That is, this is what a voltage drop across means this. This only I'm saying. Okay. So here it will be like the across, the voltage drop across will be 0.7. That is a drop. I can say this is the drop. It is 0.7. Diode become points, and it will offers a resistance RD also. Now from this, what I can say, what is the voltage across a complete like VD? Now we need to discuss. So now from that I can say where VD is equal, this whole VD is equal to this, the voltage drop across in this place is 0.7. So I will say 0.7. We know that you should think here the current is flow, right? So that the current is nothing but ID. So now the same current will flow, that is minus this minus VD is equal to RD into ID. RD into ID. See, this is very, very important here. So now from this, you can say the expression when you're going for third approximation, we need to use like this. That is the first point which gives. So second point, what it will give in the sense during the reverse bias. When it is in the reverse bias, what will happen? So that will become a same, will be itself, I will be 0, then same point will have here also. So after the infinite resistance during the reverse bias, nothing will happen. So how the diagram will come now? The diagram will become as here, same diagram like this, but this point is nothing but this point is nothing but 0.7. Okay, this is 0.7. Now I'll say till here is ideal is fine. Okay, here see, here the ideal is will get like this, because there will not be any linear, because here there is no resistance, there is zero resistance. If there is no resistance, then we'll get the curves like linear. Now see here, when I have it offers the resistance. So when it is offers the resistance, so ideal get increased. So this resistance will get like this. The slope will come in this way. Then here same reverse bias will offers. So let me take. So during reverse bias, so same point we can use. Reverse bias. When reverse bias, it offers infinite resistance. It offers infinite resistance during reverse bias actually. So now what we are going to do in the sense, so with the help of all these things, with the help of all these things, very important thing is we are going to use the third approximation. This is the third, okay? third approximation. So most of the cases we'll use the second approximation only. Now what you'll do, let us do some of the numericals here related to this. Then you'll get a proper idea how to do that. Okay, let me go for some of the numericals. Then only you'll get the idea how to do. Okay, see, this is the figure now. Okay, now for the series diode configuration, so you need to determine the diode voltage, that is VR in the sense that is reverse, okay, and diode current also, reverse voltage and diode current here. So this will be your applied voltage. Here they given E, right? So this is, don't consider this E, because for your thing will be very simple. I say, okay, this is a battery. This is battery actually. Okay, this is battery actually. Now we need to use, first thing is here, as I said, we are going to use the second approximation. That is one of the best actually normally. So what we'll do, seeing this diagram only, you say this plus to plus connected, right? Plus to plus is connected. See here, you can see simple. This plus P type is connected to positive, negative is connected to negative. So it is in the forward bias condition, as you know. If it is in the forward bias condition, then what you need to do, equivalent circuit you have to draw. So very simple, the equivalent circuit will become as like how this equivalent circuit will be there. You have to assume that there will be a voltage drop across this. So it will be like this, okay. We need to add a simple diagram. Just I will draw a simple diagram. I will replace. Okay, this is what. Now this will be your 8 volt. This is how much it is. VB is 0.7. This will be 2.2 kilo. Still, what I can do, I can redraw this diagram. How you convince? You see here, don't think there anyway diode is on. If the diode is on, in the sense the barrier the drop across is 0.7 is there. So again, you redraw this circuit. See. So this will be a plus, this will be minus. This is nothing but 8 volt. This will be your 0.7 volt. This will be your 2.2 kilo ohm. So now we can say the ID is nothing but this is the ID. Okay, diode current will flow. Now what you will do from this? What are the questions they asked? Determine VD. VD means what? The voltage drop across the diode. The voltage drop across the diode is what? Very simple. I can write from the question only. I can write. What is that? VD is equal to 0.7 volt. That is a voltage drop across the diode because this is the drop, correct? Equivalent diode. If I say VD, that is drop. So it's nothing but 0.7 volt. Okay, that I got. Now here they given is IR. So here this is IR actually. Okay, this is IR, the ID. Okay. Now this will be your they given as VR. The question itself they given. Now let us find out what is VR. That is nothing but this one. What is VR? This VR is nothing but from this question is very easy. The VR it's nothing but this battery. This battery I will you already I given this is nothing but E, right? So if I consider this is E minus this 0.7 volt. E minus 0.7 volt. Then what will be that? That is E minus 0.7 I can say, or E minus VD also I can write if you want. So let me write for your understanding purpose. E minus VD. What is E value? E value is nothing but 8 volt. VD value is 0.7 volt. So then I will get as 7.3 volt. This is VR. I got the VR also now. Next, what you have to calculate, the question they asked, calculate ID they asked. So what is ID here? You see the current ID which is flowing, the same current, correct? The same current will flow even here also, that is IR. So I can say ID will be is equal to IR. So now from this, I can say, what is that actually? IR is equal to, from this, as per Ohm's law, VR by IR is equal to VR by R. Okay, VR by R. So VR already is calculated. That is 7.3 volt divided by R is equal to 2.2 kilo ohm. 2.2 K. Then what is ID? Where ID is equal to, we have to do that, it is approximately to 3.2 milliampere. See, this is what the answer will get. ID will get VR, then VD also. So very, very simple here. You can say from the question only what you think in the sense, this just you need to replace this by this, and anyway I can say it is on. If it is on in the sense the voltage drop occurs, you can replace by this like this. You should not get any confusion. So you can do like this. Then you can perform your operations, everything. Be very, very easy. So from this I can calculate very easy. Now I will put a question to you like the same question. Repeat the above example when the diode is reverse bias. What will be the answer? What will be your answer now? So I'll go for a second question only here. Okay. Second question. I will draw the diagram. It is, you should answer now. This is 8 volt. This is, they won't give anything. Okay. This is VD. This will be your 2.2 kilo ohm. Yes. Now, just you can give your answer in the chat box. What will be the answer you will get? This is just, you see, you have to see this diagram they given. Okay. Now you have to find out just what I did the, just instead of this forward bias, I made a reverse bias here. Yes. What will be your answer? Okay. This will be your ID. Yes. This ID actually. So you can share your answer in the chat box. Yes. The answer is 0. The reason, this is the diode is a reverse bias. If the diode is a reverse bias, how the diagram will come now? Equivalent diagram. Let me draw a equivalent diagram. See this? This is equivalent, right? So this will become as like this. Circle will be become as like this. Now this is a reverse bias. With the reverse bias, what will happen? The diode doesn't conduct. The diode doesn't conduct. Then again, this figure will become as, yes. So it will be like this. When it is in this way, here ID. So what will happen? So the current will not enter over there. So from this, I can say, what will be the answer? VR will be is equal to 0. Then ID also will be is equal to 0. Very, very simple. I can write ID. This is the, from seeing this figure only, straight away you can write the answer ID is equal to 0. This will be the answer for this. I hope you might have understood that. Okay. Yes, this all about the